Section 2.1 is titled Reasoning and Logic. All right, so we're going to use some different vocabulary that you don't always see used in an algebra kind of class or something like that. So we're going to get started on that first. First one is a statement. A statement is a sentence that is either true or false.
So scaring me. I thought I was done with this stuff.
Sorry, not done with this stuff. All right, so an example of a statement. I ate eggs for breakfast. It is either true or it is false. It happens to be true today. I did eat eggs for breakfast. Okay? But either this statement is true or it's false. A non-example. What did I eat for breakfast? This is not a statement. It is neither true nor it false, because what is it? It's a question. So it's not either question or statement, okay? Those are two possibilities. There's one third possibility, and the third possibility is a command. Eat your breakfast. It happens in my house. It happened this morning, my littlest one. Eat your breakfast, just eat it. Right? That's command, also not a statement, because it's neither true nor false. So when you're trying to identify if something is a statement, you're looking for whether or not it's a true or false sentence. Okay? And so these are a couple of example, non-example. A negation is the logical opposite of a statement. It is written if the statement, oops, that was not what I meant to do. If the statement is written as P, like the letter P, then the negation is written as a tilde and then a P. And we read this as, like when we see it, we don't say tilde P. I mean, sometimes we do, but really it is read as not P. Not P. So I'm going to use that same example of the actual statement above, which was I ate eggs for breakfast. What would be the logical equivalent, the negation of that statement? I did not. Eat eggs. For breakfast. Notice, it does not say, I ate cereal for breakfast. So we want to change the very littlest bit possible when we're creating a negation to make something false. And we'll talk more about negations in a moment because they do get trickier than simply putting the word not into something, okay? This kind of a statement, very simple to create the negation for. We just say it with a not in the middle of it. I did not eat eggs for breakfast. There are two types of quantifiers. The first type is called a universal quantifier, and they refer to each and every element in the set. They use words like all, every, no, or none. These are the words that your mama's told you not to use. Never say never, right? You use the word never, you use the word always, and undoubtedly, you've probably said something that's not true. You always leave the door open. You never show me the kind of respect you should, whatever. Okay, we want to use those words very sparingly because they're usually not true. Existential quantifiers refer to one or more elements in the set. So they use the words some, at least one, or there exists. These are much less daunting of phrases. Sometimes you leave the door open, right? At least once you left the door open. like that. So I was going to write down a couple of these for you. A universal quantifier would be something like this. All boys love their mama. Okay. An existential quantifier might be something like this. Some people like swimming. Yes, Leah.
So that was going to be like a statement instead of just like boys love their mom, or instead of like taking like not writing all or something.
Like if it said, these statements wouldn't actually, they need one or the other to make sense, right? So the assumption, if you just say boys love their mama, would be that the assumption would be the word all is there. It's assumed to be there. If you saw people like swimming, the assumption would be all. Sort of the assumed statement is that the word all is there. Yeah. Okay, here's where things get tricky. When you use negations, or when you're trying to create a negation for statements that have quantifiers, that is, if you have those words, all, every, some, none, at least one, inside of the statement, and then you're creating the quantifier, I'm sorry, we're creating the negation for it, it's not a simple, let's put the word not in the middle of it. It doesn't work like that. So we're going to write the negation of the following. This says all dogs go to heaven. Okay, you've heard that phrase before. It's a movie that's titled that, in fact, as well. What is the very least? Don't think about the words. Don't think about math stuff that I've been talking about, reason and logic. What is the very, very smallest thing that could happen to make this statement false? One dog doesn't. That's all it would take, right? One dog not going to heaven would be enough to make this statement false. That's the negation. The very smallest amount of what could go wrong, it's the counterexample of what could go wrong in the statement. So if we're looking at this one and we're creating the statement, you could actually say it just like Leah just said. At least one. At least one dog, what? Doesn't, right? At least one dog doesn't. So there is a not in there, right? We don't want to say at least one dog does, because that's not changing the statement. That's just making a weaker statement than we had, okay? This one, at least one dog doesn't go to heaven. Notice, and this is not by accident, what type of quantifier is this? Look back. It's universal, the one that's circled, the one that I circled. The word all, the one that I circled, all. All is a universal quantifier. And when I create a universal, when I create a negation, what happens? It switches to an existential, and that always happens. And I did use the word always there on purpose. Okay? Really, always happens. So if you start with a universal quantifier, your statement's going to have an existential one in it, and vice versa. And the vice versa is exactly what's happening next. Some of my classes this semester are hard. So this word some is what type of quantifier? Existential. There are two ways that we could write the following statement. What word could we replace some with so that it changes from existential to universal? All or none. Okay, so I'm going to write both of them out exactly how they would be. so that you can see there are two possible answers here. One is a little bit more natural than the other one, and once we get both of them written down, you'll be like, oh yeah, I see what you mean. All. All what? If I use the word all, be careful. I'll write down what you've got so far that's okay. All of my classes. Ooh, I finally got one. Say it really loud, Ashley.
All of my classes this semester are not hard.
Are not hard. All of my classes this semester are not hard. Okay, so let's deal with a couple of different things that some of you said to make sure that we can clarify. That's what I want to talk about first. Have you ever had a class that's neither hard nor easy? I have. Aren't there some classes that you would say that are somewhere in between? That's why we can't say easy, is because it's a stronger statement than not hard. Okay? So we're wanting to change it so that the statement is as little different as possible. So we don't want to change vocabulary within the statement. So we're not going to change hard to easy. We will change hard to not hard. Now some of you also said things where you actually didn't use the word not at all. You just said are hard. So let's look at that possibility. If I say some of my classes are hard, and then I say all of my classes are hard, are those opposite statements of each other? No. They're the same statement. One's just stronger than the other one, right? Yeah. So you really do want statements that are opposites of each other. So that's why we need the not in it. So all of my classes this semester are not hard is the negation of some of my classes this semester are hard. Let's do the word none now. If I use the word none, what would I say next? None of my classes this semester. Yes. None of my classes this semester are hard. Okay, so is this the statement that is opposite of what I've gotten to begin with, where I started? Some of them are hard, none of them are hard. Yes. If you changed, and some of you were thinking maybe you need to put the word not in there again. Well, the catch is that you already put the word not in there by putting the none at the beginning, right? Some to none is already making a negation statement from what you had, some to none. So you already do have the not in there. If you use the word not again and you say none of my classes this semester are not hard, first of all, you've got a double negative in there, which really sounds awkward and difficult, right? It's what you say to confuse somebody. And you hear it done a lot, actually. You get lots of negatives in something and then nobody knows what they're supposed to be saying. Yes, no, I don't know what you just said. I have no idea, okay? So don't double negate things, all right? But in fact, it would actually be saying, if I said none of my classes this semester are not hard, it would be the equivalent to saying all of them are. And that's not what you wanted either. We want some of them to not. All of them are not hard is what we want to say. So those are your two options for how to change that, and they're both equally correct. Okay? Truth tables. A truth table is used to show all possible true-false patterns for statements. Okay? So the first truth table I'm going to show you is what a negation looks like in a truth table. So a truth table looks like, well, first of all, a table. So go ahead and make yourself sort of like a T-chart, like this. Okay. We're going to write our statement P. We'll call it P, and we'll put it on the left-hand side as the column header. And then how would I write the negation of P? What do I write? Yeah. Good. That squiggly, that tilde P. Now, there are only two possible outcomes of a statement. A statement is either true, T, or it is false, F. There are no other choices. because that's what we meant by statement, right? That was the definition. If a statement is true, what's its negation? False. And if a statement is false, what's its negation? True. So anytime you're working with a truth table and you're creating these columns, a negation column is very easy to do. It just takes everything from the original column and it reverses it. True to false, false to true. Okay, so far so good? All right, the next thing we're going to do is we're going to join statements together. Two statements that are joined together are called a compound statement. And the three types of compound statements, and everything else can be boiled down into one of these, is either a statement where we join two statements with the word and, with the word or with what we call the connective, the if-then connective. So if comes at the beginning, then comes in the middle. Sometimes I have students ask me, what about the word but? If you see the word but as a conjunction in the middle, it means and. Think about it. If I say, I ate eggs this morning, but I also ate jelly beans. It means and, right? It means I ate them both. So the statement that has the connective, if you ever see the word but, it just is the same thing as the word and. Okay? We kind of use it in a different way in our English speaking, but we mean and when we mean it. Okay, so let's take a look at the three different types of statements then. The first one is called a conjunction. Conjunction is the word and. It's equivalent of an and statement. It's true if and only if both statements are true. So if we have two statements, one of the statements is P, the other statement is Q, and we put the upside down V between them. It kind of looks like an N, a pointy N, half of an N, I don't know. Okay?
It looks like the, like, when you're not doing a square, but you're doing
Yes,
something
it
else.
looks like the carrot. That's actually what it looks the most like too when I use the computer to type it out.
What is the last one?
A Q, a P and a Q. I don't know why they like P's and Q's, but for some reason P and Q are often used. P, Q, and then R. And then sometimes S gets involved. I mean, those are the letters that statements use. It's kind of like in algebra. What letters do you always see used in algebra? X and Y. Why? I have no idea exactly why X and Y are used. But those are the sort of the default ones. For statements, we use P and then Q, and then it's usually R next if there's a third one used. And we won't go any further than that, so P, Q, and R. Okay, so we've got P and we've got Q, and they're joined with this connective that's called a conjunction. It's equivalent to the word and. So the first thing we're going to do on this one then is we're going to create what the truth table looks like. Okay, we're going to create three columns in our truth table. The first column is going to be the statement P. The second column is the statement Q. And the third column is the statement P and Q. Okay, everybody good so far? Now, one possibility is that P and Q are both true. Make sense? Okay, I ate the eggs and I ate the jelly beans. I actually ate both of them. That's a true statement if I ate them both. Both pieces are true information. If both pieces are true information, then the result with the word and between them is true. If I really did eat the jelly beans and I really did eat the eggs, I have no idea why I chose jelly beans, by the way, then it would be true to join them with the word and. I ate eggs for breakfast and I ate jelly beans. Okay, another possibility is that the first statement's true, that is, I ate the eggs, and the second statement's false, I did not eat the jelly beans. And that would be what happened this morning, because I don't have any jelly beans. We're too far removed from Easter right now, right? Okay, if I take the statements where the first one's true about the eggs, the second one's false about the jelly beans, and then I push them in together, I join both of them together, I ate eggs for breakfast and I ate jelly beans, would that be a true statement? No, because half of it was not true, right? So this statement would be false. Now, let's say that I did have jelly beans for breakfast, but I did not have the eggs. No eggs, yes jelly beans. And then I say again, I ate eggs this morning for breakfast and I ate jelly beans. Still false, right? Because half of it's false. What's the last row that's missing on this? They're both false, right? It could be that I did not eat either one for breakfast. Maybe I had cereal. Maybe I had oatmeal. Maybe I had Starburst. I don't know. Reese's peanut butter cups. Okay, then I come in and I say to you, I ate eggs this morning for breakfast and I ate jelly beans. And if both of those individual statements are false, then I mean, like, this is the worst false possible, right? It's true under no circumstances because each of the pieces were already false. Okay, everybody good with that? So I want to note something for you. I want you to notice something. What I want you to notice is that this column and this column always look like this. I always have the possibility that first two statements are true, both statements are true. The first one's true, the second one's false, or the first one's false, the second one's true, and the possibility they're both false. And these are the only ways that I can have this statement fall apart. I mean, like this is or fall into place. This is it. These are the only possibilities. These four possibilities. And the order in which I wrote them is the standard order that you will see them written. So honestly, when I write these statements down, I don't even think about them. I just know I'm going to go true, true, false, false, and true, false, true, false. They're always going to look like that. So as we go into the next one, you're going to see this exact same pattern show up again. But the last column will look different because I'm not going to do an and statement. I'm going to do a disjunction, which is an or statement. Okay? Or statement. So I have the equivalent of an or statement. It is true if either statements or both statements are true. And it is written P, Q, and it has what really looks like a V shape in between them. That's the notation for a disjunction or an or statement. So when I create my truth table, I've got the P column, I've got the Q column, and I've got the P or Q column. Just like on the last problem, I'm going to have true, true, false, false in the P column. And my Q column is going to say true, false, true, false. So even if you don't know what to do next, you can always start these problems, okay? Because they always start out the same way. Now, what we're going to do now, we're still going to use my eggs and jelly beans because I already created it. This is not my normal example for this problem, just so you know. All right, so let's say I really ate the eggs for breakfast, I really ate the jelly beans for breakfast, so both of those statements are true. And I come in to you and I say, I ate eggs or jelly beans for breakfast. That's a true statement. And it feels a little bit awkward because it feels like, well, shouldn't you be saying and? And I mean, I could be, but it is still true. Each component is true, so joining them with an or in between them doesn't make it anything different than true. It's still true. The second one, I ate the eggs and I didn't eat the jelly beans, okay? And I come into you this morning and I say, I ate eggs or jelly beans for breakfast. That's a true statement. I did. I ate eggs or jelly beans. And now it's like the day after Easter and, you know, the jelly beans are on sale half off and that's all that I have in my house. And I come in this morning because that's all I ate and I say to you, I had eggs or jelly beans for breakfast. Didn't eat the eggs, did eat the jelly beans. The statement is still true. And then the next thing happens and the eggs and the jelly beans are all out of stock because they sold them all out and I can't eat eggs or jelly beans for breakfast, so I don't have either one of them. And I come into you and I say, I ate eggs or jelly beans for breakfast, and you would have to say that that is false, that I'm a liar. That's right. Thank you, Leah. Okay, I'm a liar apparently. False statements. Okay, we're going to do one more example and then we'll quit for today. This example is going to create a truth table for a specific sequence of statements. So the statements that they're giving me is this one right here. That symbol in between, is that an and symbol or an or symbol? And. Okay, now here's the kicker. When you create a truth table, you always have all the letters that are present in your statement combined. So you're going to have a P and you're going to have a Q. You'll always have those. And then if you have any negations, you can do those next. You can work from left to right, whatever makes sense to you. So if you notice on this one, I have a negation of Q. So I have to have a column that's got a negation column for Q. Now, everything that I've written thus far is all of the individual components of this statement, right? This compound statement. I've got every individual piece. The only thing I'm lacking is the combination of all of that. And the combination will be my final column. So I've got P and tilde Q.
So even if we add components
What's that?
So even if you add components, the first two columns are still always.
Exactly. So don't skip columns. You need all of them, okay? So the first two columns are going to be true, true, false, false. And some of you, and you'll know who you are, I don't know yet for sure, but some of you are probably going to have T's and F's that look like each other. Please make sure I know which is your T and which is your F, okay? And we'll all be in a happier place. The next one is true, false, true, false. So far, so good? All right, tilde Q. So this is the first new column that we didn't actually finish filling out. What will tilde Q look like for this Q column next to it? The opposite. False, true, false, true. Now, my last column is supposed to compare the third column and the first column. So in your mind, you need to ignore column 2. Column 2's purpose was to create column 3. That's all it was. It's not used in the final composite statement, right? The final compound statement does not use it. So now we have to look at columns 1 and column 3. And when is an and statement true? When they're both true. So the first row has a true and a false in it. So what's the result of that statement? False. The second row has a true and a true in it. What's the result of that statement? True. The third row has a false and a false in it. What's the result of that statement? It is false. And the last row has a false and a true in it. And what's the result of that statement? False. And that would be the truth table that this question asked you to create. Okay?